All right, today I want to talk about some specific logarithmic property that's going to help me in the future, especially next week whenever we start solving logarithmic equations. Okay, there's three log properties I want to initially talk about. First one's called the product property. Okay, product property says that if you have log, the whole long L thing, of two things being multiplied together, two factors. It says that you can just simply take log base A of the first factor and log base A of the second factor, as long as you put a plus sign in between them. That's going to make the quotient property flow a little bit better. I'm going to have log base A of m divided by n. So it's still, I can take log base A to the m, or of m, and log base A of n. But this time, since it's a quotient, I put a minus sign in between. Finally, we have the power property. Log base A of m. I'm just going to call it to the x. I'm not sure what your book does. I'm just going to say x. It says my favorite property right here because it just makes sense. Just drop that x down in front. So it's x times log base A of m. I say it makes sense because it follows the product property. Let me just make up a number in there. If I have log base A of m squared, well, I know good and well that's log base A of m times m. Well, according to my product property, up there at the top, it says that if I have log base A of two factors, I can just split them apart and do log base A of m of each one and throw a plus sign. Well, that's the same as if I just take this 2 and drop it in front. So 2 log base A of m's. Yeah, that's what I have. I have log base A of m plus log base A of m, which is 2 log base A of m's. So the whole reason the power property works is because that product property happened up front. So let's try these with some numbers. And some variables still. I like what the homework does. It does a very good job at mixing all these up. Okay. Relax, I'm not going to work all of these. If you want to work some of these, I'll be glad to check your work. I'm just going to hit on the ones I've been doing this morning. My students have had great questions on some of these. And so, let's this first one right here, log base 7, 13x. So I really want to narrow down which property I'm going to use. To narrow that down, I'm going to look at what's happening between the 13 and the x. The 13 and the x are being multiplied together. It's a product. So product property says I can just take log base 7 of the first product and add it to log base 7 of the first product, the first factor. And that's it. That's my answer right there. I'm going to skip around some. I'm going to jump down to C. Like C, log of x. Yeah, I don't have a product there. Nothing's being divided, but I do have a power. And so to expand this, to write it as a simpler logarithm, that 7 just comes down in front. I get 7 times log of x. If you scroll on down the list, you see some of these do get a little bit more advanced. I'm going to jump ahead to D. I like D. If there's that natural log. I had a student call it ln this morning. My ears were definitely bleeding after that, but I managed. So first thing I notice on this is I have a quotient. Anytime I have a quotient, I want to take care of it first. All right. So quotient property always has to be taken care of first. So looking at this, I can take the natural log at the top and the natural log at the bottom. Just throw a minus sign. Okay, looking through there, nothing's being multiplied together, but I do have that power like I had on part C. So to get rid of that power, I'm just going to bring it down in front of its own natural log. And then this would be my final answer. Oh man, we get a little bit harder. Let's do E. Part E is I have log base 9 of xy to the 5th over z cubed. Always do that quotient property first on these. So I'm going to do log base 9 of the top minus log base 9 of the bottom. Now, last hour someone said, well, go ahead and just bring that exponent down. Second thing I really want to look for on this is any product that I have. Bringing this 5 down in front, it's really foggy. That 5 cannot travel all the way to here. That is a no-go. Instead, I'm going to notice that I do have x times y right here. So I can take log base 9 of the x plus log base 9 of the y for fifth minus log base 9 of the cubed. Now, look at what's behind all these logs now. There's only a single variable, or if one of them was a number, a single number behind all of them. That's a good spot to be in, because then I'm ready for step 3. I want to do my power rule at the very end of all these problems. So anything that has an exponent, I'm going to drop it down in front of its log. And then this would be my answer. As one more time. I've asked my morning classes to pick one. They've gone all the way down to the bottom of the list at H. Yeah, it's a good one to do H together. So I have natural log the square root of x plus 3 cube root of x minus 4 over x plus 1 to the 4th. I've got my list over here. I want to do that quotient property first. So that's just the natural log of everything that's on top. Minus the natural log, everything that's on the bottom. I'm going to be precise with this. I need to put this in parentheses. Not a big deal if you don't have it though. Product property next. Look for things being multiplied together. Well, those two are being multiplied together. So I have natural log of the first factor plus natural log of the second factor. I'm ready for my power property. Any exponent that I see is going to drop down to the front. So it's really easy to see this exponent. Ooh, but I would argue there's more exponents in this problem. If you remember the part 1 video yesterday, when I was introducing logarithms, there's a couple instances where I needed to write out the square root, that's the x plus 3, to the 1/2, to the 1/2 power. So that means the cube root would be to the 1/3 power. So square roots, cube roots, fifth roots, 10th roots, whatever roots you have on this, change them to these rational exponents, and that's going to help you get this expanded out the entire way. It's a long one. We did this one. I felt pretty confident about our homework. Now, what I do, just as a side note on this, as soon as I see a square root on the problem, I like to mark it out, put a 1/2 and a 1/3 in there. That way, I remember that at the end of the problem, when I'm ready to do my power rule, I have to bring that 1/2 and the 1/3 down. Whenever you want to change that to a 1/2 and 1/3 power, go for it. I like to do it up front. If you ask a question tomorrow that involves this, you will see me do that up front to get rid of those roots, so I don't forget about them. Now, going the other way on this is just as popular as going front ways as expanding it. It's a little bit quicker working it backwards. So what they're going to ask you to do is write the expression as a single logarithm. Now, I've got all the directions out here as to what to do, but notice the directions. What I just did last on those problems is now what I'm going to do first. Any number that I see in front of my logarithm is going back up to the exponent. Okay. Product property comes next. And then what I did first a while ago, my quotient property, I'm not doing that until the end. So I am just working this problem exactly backwards. This first one, I have 3 log base b of x plus 5 log base b of 5. First order of business every time. Let's get these exponents back home. Once that happens, look for my product rule next. So anytime I have a plus sign, that product rule is going to come into play. And you can leave your answer like this. I'm not sure what 5 to the 5th is off the top of my head. It's something pretty big, but I like this. If it was something small like 5 squared, I'd go ahead and call it 25 and put 25x cubed. This works right here for an answer. I want you to hit pause on the video and work out part B. Come back and see if we get the same answer. I hope you caught that division in there. Kind of snuck in with that minus sign. That'll work. Let's work part C together, and I'll turn you loose on part B again. Okay. Again, first order of business, get rid of these numbers in front. Working with this straight logarithm, log base 10. Common logarithm is pretty nice. I don't like those little subscripts in there. They get in the way. So first thing I want to do is I want to look for a product. I don't see any plus signs in there, so everything's going to be division on this. So what I'm going to have is I'm going to have log of v squared. Since I'm subtracting the v cubed, I know that it's going to go on bottom. The big question is, what do I do with that z squared? Where does it go? Last hour, they just told me, hey, it's z squared. So if there's a minus sign in front of it, I'm dividing by z squared. I'm still dividing right here by z squared, so it's okay to put it there. And I agree. However, I want to show you what my third hour did. It was pretty creative. They said, well, you're just dividing by v squared, and then just divide by, sorry, that should be a v cubed. It won't erase. That's awesome. V cubed right there. And I said, you know what, we can make that work, guys, because that's just log of, let's pull out that first fraction, u squared over v cubed. And then you're just saying divide that by z squared, right? Keep, change, flip says I can change that to multiplication. And yeah, I get the right answer still. So if this way makes more sense to you, that's fine. I'm here to tell you that if there's a plus sign in front of the log, it's going to go on top. If there's a minus sign in front of the log, like on these, it goes on bottom. Look what happened on part B up here. There was a minus sign in front of this y. Look where the y ended up. It's kind of a shortcut there. I'm going to let you work part D and hit play whenever you get it done. There's a couple different forms of this answer I would take. This is one of them. One thing I want to make sure you guys aren't doing, don't change this to a 1/2 and bring it down to the front. I'm not wanting numbers in front on this. So we're just going to leave this one as a square root. If there was a 1/2 in front, then yes, I would move it up. But there's not. So be careful with that. Hope you got that one. Last up, we have the change of base formula. Change of base formula is simply a ratio of logarithms that have a common base. And so we saw some in the homework last night where we always ask ourselves on this, b raised to what power gives me m, correct? And we did them mentally. Some of them where it was a common logarithm or natural logarithm, we typed them into our calculator. Well, I'm here to give you a change of base formula and just simply say that you can just take a log of this m right here and divide it by log of your base. It's just a ratio of logarithms. And as long as you have the same log base on top and bottom, it works. So if you're more of a natural log type person, you can just hit natural log of m divided by natural log of b. Very first time I taught this lesson, there was an older gentleman in the class at my class at ASU that asked me, said, why does that happen? And I wish I knew the answer at the time like I do now. Because now I know that log base A of m, that this is true if and only if, by definition, I'm going to change this to a b. If I have b to the y is equal to m. What we did in the introduction to logarithms was we switched it from logarithmic form to exponential form and exponential form to logarithmic form. And just like everything else in algebra, if I add 7 to one side, I have to add 7 to the other. If I take a log of one side, we're going to see this next week, I have to take log of the other. Using my power property, my goal is to get my hands on this y. I want to know what y is equal to. So I'm trying to solve this for y. I can drop this y down in front of the logarithm and then just divide both sides by log of b. And sure enough, I wish I could have told that older gentleman that is why that happens. If I would have thought of it at the time, I definitely would have. All we need to know is the formula for this. So evaluating these logarithms, this would be tough trying to do mentally, all right? So yesterday we were asking 5 raised to what power gives me 77? I have no idea. 2 point something, because it's between 25 and 125. I don't know exactly where. This change of base formula says that I can just take log of this 77 and divide it by log of 5. And whenever I do that, I do believe I get 2.699. So 5 to the 2.699 gives me 77, or at least something close to 77. You try this next one, see what you get. Did you get a negative answer? Maybe a negative 1. 0.792. Any questions on this, please let me know. This is going to be very key, like I said, to stuff we're going to be doing next week when we start solving. Got to be able to expand and condense and get stuff written a little bit differently. So, good luck.